Welcome viewers. In this video we'll see the problem based on the mesh analysis by equation method containing the 3 loop. The question is find the loop current and also find the power absorbed by 8 ohm resistor. Consider this diagram. Circuit network is available. The question is we need to find the loop current I1, I2, I3 and also power absorbed by this 8 ohm resistor. So in this we have two voltage sources available, 100 voltage and 40 voltage. So this is nothing but a first loop. The current is flowing in a clockwise direction. This is a loop 2, I2, current I2 flowing in clockwise direction. This is loop 3. The current I3 is flowing in clockwise direction. The current direction taken as same current direction. Direction is same for all three loops. Loop 1, loop 2, loop 3. The current is I1, I2 and I3. So our aim is to find the value of current I1, I2, I3 and also one more question, what is the power absorbed by this resistor? P equal to V into I, that is this V. The I is nothing but I1. So V into I1, if you multiply you will get the power absorbed by 8 ohm resistor. But so by using this equation method we need to frame the three different equations by using the Kirchhoff's voltage law. For loop 1, loop 2, loop 3. We need to frame three equations. By solving these three equations, we can find these three currents I1, I2, I3. There are three loops available. So we need to frame three equations. By solving the three equations, we are able to find these three loop currents. Now we'll apply the Kirchhoff's voltage law to the loop 1. What is Kirchhoff's voltage law? The potential rise equal to potential drop in a closed loop, or total potential in a closed loop is 0. So what is potential rise? This 100 voltage is a voltage source. This is a potential rise. This 8 ohm and 4 ohm available. This is potential drop. Voltage is dropped across 8 ohm and 4 ohm. So this 100 voltage is equal to voltage drop across 8 ohm and 4 ohm. So that is given by the Kirchhoff's voltage law. Potential rise equal to potential drop. Right? So based on that we can frame the equation. So potential rise 100 equal to, here this is the supply voltage, so that 100. See the current direction, it is flowing in clockwise direction. That is from, in this source it is flowing from downward to upward. That is minus to plus, negative to positive. So that 100 voltage. Voltage is rising here. See the direction. So it is going like this. It is going upward. So it is going like this, negative to positive. So that here 100 voltage. What is the voltage drop across this 8 ohm? V equal to I into R. What is I? I1. I1 is flowing through 8 ohm. So 8 into I1 is the voltage drop. Right? So in 8 ohm only I1 is flowing. So 8 into I1 will give the potential drop. What about this 4 ohm? So in the closed loop what we have? This 100 voltage, 8 ohm and 4 ohm. This 4 ohm, what are the current flowing? See that there are two currents are flowing through the 4 ohm. So because it is connected common between loop 1 and loop 2. See this I1 current is flowing and also I2 current also flowing. I1 current is flowing downwards. I2 current is flowing upwards. Both are opposite direction. So we need to subtract. The difference between these two current will be flowing through 4 ohm resistor. So that 4 I1 minus I2. Right. So in the 4 ohm connected between loop 1 and 2. So I1 current is flowing in downward direction. I2 current is flowing in upward direction. See the direction, upward direction. Both are opposite. So difference between these two current will be flowing through 4 ohm resistor. So that drop is 4 into I1 minus I2. While referring loop 1, I1 minus I2. If you refer loop 2, I2 minus I1. So we frame the equation 1. Voltage rise 100 equal to voltage drop across 8 ohm resistor, voltage drop across 4 ohm resistor. Now we frame the equation 1. Now we will consider the second loop. Loop means closed circuit. In the second loop, what are the resistors available? 10 ohm, another 10 ohm and this 4 ohm. These three resistors are available in the second loop. First we will find the what is the current, what is the drop across this 10 ohm. Here the voltage source is not available, so it is 0. Potential rise or drop, potential rise is not available. Voltage source is not available, so it is equal to 0. What is the voltage drop across this 10 ohm resistor? This I2 is flowing through the 10 ohm. So 10 into I2 is the potential drop across 10 ohm resistor. What about this another 10 ohm resistor? This I2 is flowing in downward. This 10 ohm is connected between loop 2 and 3. So the third loop current I3 also flowing in upward direction. See, the current direction is coming like this and going upward, but this current is going downward. So both the currents are opposite direction. I2 is flowing downwards, I3 is flowing upwards. So I2 minus I3, difference between these two, I2 minus I3 is flowing through the 10 ohm resistor. So the drop across 10 ohm is 10 into I2 minus I3. Then we have one more resistor, 4 ohm. We already discussed. This 4 ohm resistor, I1 is flowing downward, I2 is flowing upward. So already we discussed I1 minus I2. But while referring the second loop, we need to write I2 minus I1. While referring first loop, I1 minus I2. While referring second loop, I2 minus I1. Because we are taking 2 as a reference. Now we calculated the drop across this 10 ohm resistor and another 10 ohm resistor and this 4 ohm resistor. So this is equation number 2. We framed the second equation also. Now we'll go to the third loop. In third loop, what are the elements available? This 10 ohm resistor, this 4 ohm resistor and one voltage source is available. So potential drop, potential rise equal to potential drop. First we'll consider this 40 voltage source. See this, how the current is flowing in the downward direction, that is from positive to negative. It is flowing like this, from positive plate to negative plate. So this is a drop in potential. So we need to take minus 40. But in case of the first source, the current is flowing from bottom to top, negative to positive. So that plus 100. But here the voltage is going downward direction, that is from plus to minus. So that there is a drop in potential. From it is going from positive to negative. Potential is dropped here. So minus 40. Then what are the resistors available? This 4 ohm and 10 ohm. In 4 ohm only I3 is flowing. So 4 into I3. In this 10 ohm, we already discussed I2 and I3 is flowing. I2 is flowing downwards, I3 is flowing upwards. Both are opposite direction. So the difference between these two current will be flowing through 10 ohm. But while referring the loop 3, we need to take I3 minus I2. While referring loop 2, I2 minus I3. That is the only difference. So this is the potential drop. It's a voltage source. This is the drop across 4 ohm and this is the drop across 10 ohm. So we framed the equation 3. Third equation also framed. Right? By using the KVL for loop 1, loop 2 and loop 3, we framed the 3 equation. By solving these 3 equations, we are able to find the value of I1, I2 and I3. Before solving, we will simplify this equation. Equation 1, 2 and 3, we will simplify. After simplify, we will go for the solution. Now we will consider the first equation. So this first equation is 100 equal to 8i plus 4 into I1 minus I2. So it is written here. First equation. Now we will simplify this. 100 equal to 8i. This 4 is multiplied inside. 4i1 minus 4i2. This 4 is multiplied inside. So this 100 equal to 8i and 4i. 4i1. I1 available 2 times. 8i1 plus 4i. So this 12i1. This I2 minus 4i2. We will rewrite this. So that 12i1 minus 4i2 equal to 100. Right hand side and left hand side terms are interchanged. Now we can divide this equation by 4. So here 12, 400 is available, so that we can go for further simplification. The entire equation is divided by 4. So 12 divided by 4, 3. 4 divided by 4, 1. 100 divided by 4, 25. right? So the equation 1 is now simplified into the form that we consider as equation number 4. 3i1 minus i2 equal to 25. Equation 1 is now simplified into form and is considered as a equation number 4. Now we'll consider this second equation. 0 equal to is available here. 0 equal to 10i2 plus 10i2 minus i3 plus 4i2 minus i1. Now we'll multiply this inside. So 0 equal to 10i2 plus 10 into i2 minus 10 into i3. Similarly 4 into i2 minus 4 into i1. This 4 is multiplied inside. Similarly here 10 is multiplied inside. So 0 equal to, so this i1 is available only one term, minus 4i1. This i2 is available here, 10i2, here one 10i2, here one 4i2. So 10 plus 10, 20 plus 4, 24i2. i3 only one term is available, minus 10i3. Now i1, i2, i3 everything are added and the equation is framed. Now rewrite this, minus 4i1 plus 24i2 plus 10i3 equal to 0. This right hand side and left hand side terms are interchanged. So here also we can divide by 2 for further simplification. 4 divided by 2, 2. This minus 4 divided by 2 is minus 2. 24 divided by 2 is 12. Minus 10 divided by 2 is minus 5. Right? Now the equation 2 is simplified. Minus 2i1 plus 12i2 minus 5i3 equal to 0. We'll take this equation number 5. Right? Now we'll consider this equation 3. We will simplify this equation 3. So equation 3 is minus 40 equal to 4i3 plus 10i3 minus i2. Now we'll go for further simplification. We can multiply this 10 inside. So minus 40 equal to 4i3 plus 10 into i3 minus 10 into i2. See, this is the i3 available, 2 terms available, 4i3 plus 10i3. So 14i3. 10i2 is available. So this equation also we can divide by 2. So for further simplification. Minus 40 divided by 2 minus 20. 14 divided by 2 7. Minus 10 divided by 2 minus 5. Now rewrite this. Multiply with the negative. Right? So this minus 20 become plus 20. 7i3 become minus 7i3. Minus 5i2 become plus 5i2. Now rewrite this. So 5i2 minus 7i3 equal to 20. Right? So the equation 3 is simplified and divided by 2, multiplied by minus 1 and framed the simplified equation. We'll take this equation number 6. Now equation 1, 2, 3 is simplified and it's given the new name, new number 4, 5, 6. Right? So these equations are available here. So this is equation 4, 5 and 6. Now we need to solve these equations. By solving these 3 equations, we can be able to find I1, I2 and I3. First consider this equation 4 and 5. We will cancel this term I1. How will you cancel? See here 3 is available, here minus 2 is available. So equation 4 is multiplied by minus 2. Multiplied by 2. Similarly, equation 5 is multiplied by 3. If we multiply in opposite side, both become 6i, so that we can easily cancel. Right? So this equation is multiplied by 2. This equation is multiplied by 3 in order to cancel I1. Right? So equation 4 multiplied by 2. What happened? 3i1 is 6i1 minus 2i2. 25 into 2, 50. Equation 5 is multiplied by 3. Minus 2 into 3, minus 6. 12 into 3, 36. 5 into 3, 15. I3 equal to 0. Right? In order to cancel the term I1, here the coefficient 3 is available, here coefficient 2 is available. So oppositely it is multiplied. This is multiplied by 2, this equation multiplied by 3, so that we are getting the same coefficient. Now 1 is plus and 1 is minus. So by simply adding these 2 equations, we can easily cancel this term. Right? We can add. No need to go for subtraction because 1 is positive, 1 is negative. By simply adding, this term automatically got cancelled. So sum of these two, 36 minus 2 is 34. Right, I3 is not available here, 15 I3. Now in this side also this is 50, this is 0. So 50 plus 0, 50. So now we got, after simplification, we got 34 I2 minus 15 I3 equal to 50. Let's take this equation number 7. So here only I2 and I3 is available. I1 is cancelled. Now refer the sixth equation. Here also I2 and I3 is available. So we can cancel either I2 or I3 between these two equations. Now we'll cancel this I2. How will you cancel this? Here 5 is available, here 34 is available. So we can multiply this equation with 34. Similarly, we'll multiply this equation with 5. So that both the coefficient become equal and can cancel the I2. Now we'll go for that. So equation 6 is multiplied by 34. Equation 7 is multiplied by 5. Right, so that we got this value. See here both are 170. So we can easily cancel. But both are positive here. So we need to subtract. Then only it become cancel. The previous case one is positive, one is negative. So easily we cancel. By adding automatically it got cancelled. But here both are positive. So we need to subtract. So we'll subtract, what will happen? One is positive, negative means cancel. So here subtract, it become plus because we need to subtract. So minus 238 plus 75, that is nothing but minus 163 I3. Here also you have to subtract. 680 minus 250 is 430. So that I3 equal to minus 430 divided by 163. So I3 equal to minus 2.64 ampere. So now we got the current value I3, loop 3 current I3 value is calculated. By solving the equation, the first current is calculated. Now we can substitute this value in the sixth equation. Consider the sixth equation. If we substitute I3 value, automatically we can find I2 value. Right? So consider the sixth equation. 5I2 minus 7I3 equal to 20. In that we are going to substitute I3 equal to minus 2.64. So while substituting, what will happen? So 5I2 minus 7, I3 is minus 2.64, that is equal to 20. So 5I2, so both are negative. So 7 into 2.64 is plus 18.48. This is minus 7, this is also minus. So become plus, that is equal to 20. So 5I2 equal to 20, bring this term in the right hand side. So 20 minus 18.48, here positive are, that become negative. So 20 minus 18.48 is 1.52. So 5I2 equal to 1.52. So that I2 equal to 1.52 divided by I. So 1.52 divided by I is 0.304 ampere. Now we got the second loop current I2 also. I3 already calculated. By substituting this, we got the I2 value. So by using the I2, we can be able to find the I1 current. In order to find the I1, consider the equation number 4. Here I1 and I2 is available. So by substituting I2, we can easily find I1. So substitute I2 equal to 0.304. So 3I1 minus I2 is 0.304 equal to 25. Bring this minus 3.04 in the right hand side. So that 3I1 equal to 25 plus 0.304. So by adding these two, 25.304. So 3I1 equal to 25.304. So I1 equal to 25.304 divided by 3. By simplifying, we got 8.44 amperes. So the I1 current is 8.44 ampere. Now we got all three currents, I1, I2 and I3. In that I3 is negative, I1 and I2 is positive. What is the meaning why we got the I3 is negative? We assume the I3 current is flowing in clockwise direction, but we got the answer as negative. It means that the current is flowing anti-clockwise direction, right? So you can take any direction. Accordingly, you will get either positive current or negative current. We got the negative current, that indicates the direction what we assumed is not correct. The current is flowing in opposite direction, that is anti-clockwise direction. Now one more question is there. Power absorbed by 8 ohm resistor. What is 8 ohm resistor power? Power equal to V into I. So the 8 ohm resistor connected near 100 voltage. The current flowing the 8 ohm resistor is I1, 8.44. So 844 watts. Right? Power absorbed by 8 ohm is V into I. This 8 ohm is connected nearby the voltage 100. The current flowing through this 8 ohm is I1, 8.44. So 100 into 8.44 is 844 watts. So in this problem, we consider the mesh analysis. The problem is solved by equation method by using the Kirchhoff's voltage law. The same problem solved by matrix method. That another video is available. The link is available in the description box. You can view that same problem solved by matrix method. Thank you.